Okay, this is problem number 1, and what was given here is calculation of molarity, which is a concentration, and they have given you the mass of solute, and they give you the volume. So essentially, they want you to figure out, you have a mass, can you calculate number of moles of the solute, and then a number of moles divided by total volume of solvent. That's what we call the molarity. So the mass here is 97.7 gram. And so what is a mole of lithium bromide here? And I guess that's figuring out the molecular weight. So if you're looking at the periodic table, the lithium has an atomic weight of 6.94 gram per mole, and the bromine is 79.9. So if you add it up, that will be 86, 84. The unit is gram per mole. So once again, if you have 1 moles of lithium bromide, it will weigh 86.84. So therefore, what you want to know, moles of lithium bromide is mass 97.7 gram divided by their molecular weight, and that's that's a gram per mole. So 97.9, 86.84. That will make you 1.13 mole of lithium bromide. And what was the volume? And 750 milliliter. I want to change to in the unit of liter. And so this is what I have. So therefore, concentration in the unit of molarity is 1.13 mole, 0.75 liter. That will get you 1.5 molar concentration. So answer here will be D. Okay, the problem number 2. It is essentially understanding the conjugated acid pair. So conjugate acid and base pair. Example, if acid is called HA, when you lose the H plus, it became H minus. So these are the base and the conjugate acid pairs. And also the other one is conjugate base and the base acid pair, which is B as a base. If they receive a proton, H plus, as B becomes Hb plus. So these are the pairs of base and the conjugate acid. So this let's look at here. And so the first example is HO minus. So if they receive an H plus, so you add an H plus here, and there will, I guess it will be H2O. So this is not H2O. So that's not the case. What about HO minus losing H plus and O2 minus? This is unlikely, but there's another example, but I don't see them. So I guess this is not the other one. Not the case. I guess so we got lucky that answer is A. Let's check on the answer here. This is a base, and you receive the H plus, so therefore you have extra H's, and the charges became one more positive. And this one is, looks like by going here, you're losing the proton, so this is an acid to conjugate base. In this case, you lose H to becomes the other side, so then that's the acid and conjugate base pairs. So the answer for this one is A. Okay, so the problem number 3, this is a continuation of, I guess, acid-base chemistry. And they give us a mass, and this is a monoprotic acid. That's good. And KHP. KHP is actually known as potassium and hydrogen phthalate. You don't have to know the chemical structures, but H plus, K is a potassium, K plus, and hydrogen phthalate means, this is a phthalic acid, and they're the mono acid, protic acid form. So there is actually, therefore, this H plus, this H can be loose in a form of an acid. So make this one as an H, as a monoprotic acid. At any rate, the KHP, once again, potassium hydrogen phthalate, has a molecular weight, it says 204.2 gram per mole. So this is an important information that I will retaining because I know the mass was given. And the sample was titrated with this concentration of calcium hydroxide. So calcium hydroxide, it's important to understand, know the calcium hydroxide, the chemical structure. The calcium is, as you know, calcium is calcium 2 plus. So therefore, hydroxide is OH minus. You need 2 of them to neutralize it. So therefore, CaOH2. This is their formula, chemical formula. So therefore, the one thing that the question is being asked is, okay, so 0.0703 moles of calcium hydroxide solution. And what that means is, as far as the OH minus concentration is concerned, it is a 2 times of 0.703 molar. Okay, and so that will make it as OH minus concentration as 1.406 molar. And then now you have given that 6.74 grams of acid, KHP, which is on acid, and divide by their molecular weight, 204.2 gram per mole, KHP. That will give us the number as 0.033 mole of KHP. Okay, so we got this compound that contained in this acid over there, and that will be the molar concentration of KHP. And this one will be reacted. So this is, in a way, the same statement can be made as same moles of H plus can be generated from the KHP. Okay. So now the question is, what is the volume of the base was used for the titration? So this is same as for the titration. You have a same number of H plus and OH minus. So therefore, you can say that I have OH minus mole should be same as H plus mole, so 0.033 mole is okay. So this is a concentration that I have OHs here, 1.406 times volume in unit of liter. That will give me the therefore volume is 0.0223 liter. That makes it 23 milliliter. And I can say that the closest answer that I have is C.